All right, so this is the Igcse 2 Congruence and Similarity practice exam. Now, explain why the two triangles are congruent. So now all we have to do on this is actually go through our notes and find the different ways. We have 5 different ways to find that it's congruent. And one that we look at it, all we have to do is go through and read what we have. This one's angle, side angle, angle, side angle. So that's all we have to do is actually match that up. So that's angle, side, angle for that one. Now on the next one, okay, it says, why are they not congruent? So when you're reading through the test and actually doing the test questions, you need to make sure you're reading everything carefully, okay, for each question. Otherwise, you might get something wrong because this is why they are not congruent. Now, if we go through this, we have angle, side, side, angle, side, side. Okay, so now angle, side, side is never one of our congruencies. It actually says in your notes, so angle, side, side. So that's why they are not congruent. Angle, side, side is not a possible way for them to be congruent to each other. So if you remember, don't be an ass. Okay. All right, so now, right here, AB is parallel to DE. So that is very important for this. So if AB is parallel to DE, if I go through my notes, I can find with parallel lines, I know that we can have alternate interior angles. So alternate interior angles would be this and this. So I'd say that this would be angle BAC is congruent to angle. So it's BAC, congruent to DEC, DEC. And it'll also give me another one where it is on this side here, here and here. So those are also alternate interior angles. So I could say that angle ABC is congruent to angle, that one's going to be EDC, and then so the reasons for that is alternate interior angles. So that's the reason for those. And what else? We have AC is equal to CE. So AC, which is this piece here, is equal to CE, which is this piece here. And the reason for that is because this was given. So that was given to me. Then, if I look and read through this, this one's going to be, it is going to be angle, angle, side. And this one also is angle, angle, side. So I could state that the triangle, so this is actually going to be my congruent statement. So triangle ABC is congruent to triangle CDE, and my reason for that is going to be angle, angle, side. Okay, now for this next problem here. This next problem, what I'm going to do is I'm going to different colors for each of these and make it a little bit easier so you can see these, because these are overlapping triangles. So it's kind of hard to see unless I highlight them differently. So I have a right triangle, so I'm going to draw this one here. So right triangle there. And then I have another right triangle here. And this is the triangles that we're talking about. So they're overlapping. So if I come off to the side, separate them, and I could actually itemize each piece. So I can go through and mark each piece. So if I know that they're right. So this is a right, so that's important. So those are right. That's what that symbol is. Now, they both have the same line in common. So they both have AC. So if I look right here, AC is the hypotenuse of the yellow one. AC is the hypotenuse of the green one. So those are congruent also. And it also gives me this piece right here, which is, it says this piece is X and this piece is also X. So no matter what X is, they're both going to be the same thing. So I'm going to state that this one and this one, so if I'm looking at the triangle, that's going to be this one here, and it's going to be this one here. So now for this one right here, I'm going to have angle, angle, side, and this one is also angle, angle, side. So I'm going to state that this is going to be, so for part A, I'm going to state that triangle ACX is going to be congruent to triangle ACY, and the reason for that is what? it is going to be angle, angle, side. Angle, angle, side. Now for part B goes with A. So if I already know that these are going to be congruent to each other by angle, angle, side, I can go back and actually use the fact that they're congruent. So if we already know that they're congruent, that means that all parts are going to be congruent. So if they're already congruent to each other, we can know that this one is going to be congruent to this one. Same thing, this one, that's 3 lines there, is going to be congruent to this one. So because they're already congruent, so that already matches up. So I could state that AY is going to be equal to CX, okay? And the reason for that is corresponding parts of congruent triangles are congruent. CPCTC. That's the reason for this. So if they're already congruent, I could state anything about those two triangles being congruent already. All right, number 5, explain why the triangles are similar. If I look right here, this one's 52, so that one goes with this one here. This one's 55. I'm going to double arc that one. That one's 55. So now, because I'm looking for similarity, I have the postulate to go along with that, which is going to be angle, angle. So for part A, that's going to be angle, angle, similarity. So angle, angle, similarity. That's all I need to actually prove that the triangles are going to be similar. It's just 2 of the angles go along with each other. Now also, for part B, to be able to solve that, once I state that they're similar, I could use cross products. So I'm going to use cross products. I have 6 over x, so this one with this one equals 7 over 24. Because since this one is on top over here, that means 7 must also be on top on this one here. Cross products, and I should get 144 equals 7x. Divide both sides by 7, and I get x is 20.6. That's about 20.6. So we get 20.6 centimeters is my x value. Now, for number 6 here, okay, they already are similar, so that's important. Since they're already similar, we already know that we can just jump straight to my cross products. So I'm going to go with 5 over x equals 8 over 32. Cross products, and this should be, let me see, 150, 160. Equals 8x, divide both sides by 8, and I get x is equal to 20. So x is 20, and my units on this is going to be centimeters. Okay, so now let's take a look at number 7. So for number 7, I'm going to do, it says, use similar triangles to find the value. So it's basically implying that they are already similar. So now I'm going to set up my proportions. So I'm going to start off with 2, because that's the small triangle. So 2 over, now the big triangle would be the whole thing, and that's going to be my x, equals my small triangle, which my value is 4, over 6. Now I'm going to go through and do my cross products, and I get 12 equals 4x. Divide both sides by 4. I get x is, let me see, 3. And so it's going to be 3 centimeters. All right, so for number 8, we're going to do the same thing as we did on 7. So use similar triangles. So this one right here, I'm going to start off with 8 over 12. So 8 over 12 equals, now 8's a small triangle and 9 is a small triangle here, over, now the big triangle is all the way from here to here. So if it's from here to here, I need to have all of that. So I'm going to say that's going to be 9 plus y. So that's going to be a binomial there. So it's going to be 9 plus y. So I'm going to have my cross products, which is 8 times 9 is 72, and 8 plus y plus, 8 times y is 8y, and then equals 12 times 9 is 108. Now I'm going to subtract 72 from both sides because I'm trying to get my y by itself, so I should get 8y equals 36, and then divide both sides by 8, and y is equal to 4.5, and my units here are going to be in centimeters. So we found the value of y there now. Now let's take a look at number 9. Number 9 says use similar triangles to find the value of x. So it's already stating, implying that they're similar, so I'm going to put them together. So it's going to be 35 over x equals, so 35 is a big triangle, so that means that I need to put 25 on top over here, so 25 over 5. Now I do my cross products. 160 equals 25x, and I don't think I like that. So let me see. 20, 15, 75. Calculator. Clear. I have 35 times 5. 5 times 3, 5. 175. So 175 equals 25x. I'm sorry, I apologize. So now from there I could divide both sides by 25. So I should get x is, so 175 divided by 25, 7. X equals 7. Now my units on that is going to be in centimeters. There we go. And then on this next one here, which of the following are not similar to each other? Now, all the rules that we had for similar shapes and similar solids and all those other things, now 2 squares are going to be similar, 2 rectangles could be similar, and 2 regular pentagons can be similar, but the problem is 2 circles cannot be. There is no angles, there is no sides, there is no lines to go along with it. So in questions like this, you just look to see one of these things is not like the other. I'm not going to sing the song. Okay. All right, so now we're going to do the same thing for 11, but on this one right here, we're going to find the length of x. So I'm dealing with area here. So since I'm going to deal with area, so I'm going to start off with this one over this one. So this is area, and I know area is always squared. So I'm going to have 5 over 20, and I reduce that. So I need to reduce. So if I reduce it in my calculator, so 5 over 20 reduces to 1 over 4. So it reduces to 1 over 4. And since it is area again, we know that area is always square. So to get the scale factor, I need to take the square root. So I'm going to take the square root of 1 over 4, which will give me 1/2. And this here is my scale factor. So that's going to be my scale factor. So that's going to help me find this missing side over here. So I'm going to use my scale factor of 1 over 2 equals, now 1 goes with the small one, the 2 goes with the big one, right? So I'm going to put 4 on top over x. And then I'm going to do my cross products again. So I get x equals 8. Because I get 1x, 2 times 4 is 8, so x is equal to 8. So it's going to be 8 centimeters there. All right, now on number 12, it's just like number 11, but this one we're dealing with volume. So the first thing I'm going to do is I'm going to figure out my scale factor. So I'm going to compare these two pieces. So if I have this one over this one, it's not the volume I'm comparing, I'm just comparing one of the lengths that I have. So right here, I'm going to have 5 over 10. That reduces to 1/2. That reduces to 1/2, and since you notice they're not square, they're not cubed, so this one, the scale factor is right here. So this is my scale factor. That's important. That's a scale factor. And now to figure out the volume, we know that volume is always going to be cubed. So since the volume is going to be cubed, I'm going to take this value right here, which is 1/2, and I'm going to cube it because I'm going to the volume. On the previous problem, I actually took the area and went down to the scale factor. This one, I'm taking the scale factor and going up to the volume. So this one, I have to cube it, and that's going to give me 1/8. So the volume scale factor is going to be 1/8. So I use 1/8 equals, now the 1 goes with this one, the 8 goes with this one. So if the 1 is on top here, the x goes on top over 600. I do my cross products and I get 600 equals 8x. Divide both sides by 8. Let's see, I can't do that one in my head. 600 divided, on works. 600 divided by 8 gives me 75. X equals 75, and it's going to be cm cubed. So my answer is going to be 75 cm cubed because I'm dealing with the volume there for that one. So I went, the reason why this one's different because it is volume. On the previous problem we did area. So, and on number 13, we're going to do all 3. We're going to do all 3 on this one here. So we're going to take a look at this. It said 2 hemispheres are similar. Find the volume ratio. So volume ratio, so I'm going to use the volume first. So I'm going to take this and I'm going to have, so for part A, it's going to be 8 over 64. Now I reduce it. So reduce. To reduce it, don't forget, you just put it in your calculator to get the reduction. So it's 8 over 64. So let me see if I could do mine. 8 divided by 64. And then I have to go on mine. I go here, there, 1/8. There we go. See, 1/8. So it's 1/8. So the volume ratio is 1/8. Now, to find the length ratio, that's going to be the scale factor. So to get the scale factor, since I'm dealing with the volume and I know that volume is always cubed, I have to take my 1/8. So for part B, I take my 1/8 and I have to do the cube root. So I take the cube root of this and that's going to give me my length or my scale factor. So take that, so cube root of 1/8. So, you know what, I'll grab my calculator. I'll grab one of these because I'm going to do it the same way you guys have to do it. So I don't want you guys complaining and saying, oh, you didn't show me how to do it on our calculator. Okay, so this calculator right here, so have the same thing you have. So I'm going to do the cube root. So for right here, it's going to be control here, and that's where I put my 3. And inside there, I go 1. And to do my fraction, 1/8. And I had to do control here to actually do that. So I have my cube root of 1/8, and I hit enter, and it's going to give me my 1/2. So 1/2 is my length ratio, or also referred to my scale factor. And for part C here, the area ratio. So now I know what the scale factor is here, and to find the area, I always know that area is going to be square. So I'm going to take my 1/2, which is my scale factor, and I'm going to square it. So I'm going to take this and square it. So I take, and I'm going to do parentheses, right here, so parentheses, 1/2, and I'm going to close that, and I'm going to square all that. So there's that square button right there, and I'm going to hit enter, and it gives me 1/4. So this one gives me 1/4. So that is actually the area ratio.